Hello and welcome to my walkthrough video for my AQA Higher Paper 2 practice paper. I've created this paper using the key topics revision list that you can find on my website. If you'd like to give this paper a go beforehand, you can find the link to it in this video's description. Otherwise, let's go through the answers. So for this first question, we've been asked to write the ratio 17 to 40 in the form n to 1. This just means we need to rewrite that ratio and simplify it so that there's a 1 on the right hand side. So let's take the ratio, and then we need to write it so there's a 1 on the right hand side. So what would we do to get from 40 down to 1? Well, that's just divide by 40. And if we do that on the right hand side, we also need to do that on the left hand side. So 17 divided by 40. Now remember, you have a calculator for this paper, it's paper 2, so you can just type that straight into your calculator, and it gives you the answer 0.425. So the answer to the question is n equals 0.425. For this question, we need to expand and simplify some brackets. So what we're going to do is take these brackets and multiply all terms in the first bracket by all terms in the second bracket. Let's start with x times x. That gives you x squared. Then x times negative 3, that's negative 3x. Then a positive 4 times x, that's plus 4x. And finally positive 4 times negative 3, that's negative 12. Now we just need to simplify, we've got two terms here in x, negative 3x plus 4x is positive 1x. So we end up with the answer x squared plus 1x minus 12. For this question, we have Sasha who's answering some questions. She's got 27 correct and 33 wrong. So let's add up the total number of questions first of all. We've got 27 plus 33, which is 60 questions total. We've been asked to find the relative frequency for correct answers. So this is just the number of correct answers divided by the total number of answers. So there were 27 correct over the total of 60. You can leave your answer like this, but you could also give it as a decimal if you prefer, that's 0.45. For this question, we need to work out the bearing of B from A. So imagine you were stood at the point A, you were facing in a north direction, and you needed to turn clockwise so that you face B. You would turn through this angle here. So we need to find the size of that angle. Now these two angles are around a point, so we know they add up to 360 degrees. So if we do 360, take away 298, we find our missing angle at 62 degrees. Now when you give a bearing as an answer, it should always be 3 figures, but 62 is clearly 2 figures. So we need to put a 0 in front of it, so it's 062. For this question, we need to find the highest common factor of 56 and 70. Now the first thing we're going to need to do is prime factorize both of those numbers. Now you could do this with a factor tree, however if you have your calculator it's highly likely to be able to do this for you. So I would start off by pressing 56 and then pressing equals. This just sets 56 into your calculator. Then if you press shift, which is likely in the top left of your calculator, and then there's a button which says fact, F-A-C-T in capitals. If you press this, then equals, it should tell you that 56 is the same as 2 cubed times 7. Then if you do the same for 70, so press 70, then equals, then press shift, then fact, then you'll find it's 2 times 5 times 7. Now I'm just going to rewrite the first one, 56, instead of 2 cubed times 7, 2 times 2 times 2 times 7. Now we're going to draw a Venn diagram and put these factors into it. So the first circle is going to represent the number 56, and the second one is going to be the 70. Now we look at those prime factors and we're looking for numbers that are in both of them. So I can see we've got two 2's here, so I'm going to cross those out and put 1 2 in the middle to represent them. Then looking across, I've got no more 2's in the bottom one, so I can't use 2 again. I can't use 5 because there's not a 5 in the 56, but I can use this 7 at the end. So I cross off those two 7's and put a 7 in the middle. Now there's nothing left that matches, so these two 2's here in the 56 are going to go in the 56 circle, and this 5 at the bottom is going to go in the 70 circle. Now to find the highest common factor, you just multiply the bits in the overlapping section here. So we're going to do 2 times 7, which gives you the answer 14, and that's the answer to the question. Now had they asked you for the lowest common multiple instead, it's worth knowing you would multiply all of the numbers in the Venn diagram. So if it was the lowest common multiple, you'd do 2 times 2 times 2, so that's 3 of the 2's, times 7 times 5. For this question we need to do an error interval. I like to do these by drawing out a number line. I'm going to place the number from the question, 330, in the middle. This number's been rounded to the nearest 10 milliliters, so I'm going to add 10 milliliters and subtract 10 milliliters from it. So if I take away 10, I get 320, and if I add 10, I get 340. Then the error interval will be represented by this shaded region here. So I need to know the number in between 320 and 330, and also the one between 330 and 340. So the one from 320 to 330, that's 325, and the one in between 330 and 340 is 335. So these are the bounds for my error interval, so it's 325 at the bottom and 335 at the top. For the second part of this question, we have a larger cup and it has 3 times the capacity of the smaller cup. Now you may notice this part's only worth 1 mark, so all we need to do is multiply the previous error interval limit by 3. So we're going to do 325 times 3, which is 975, and 335 times 3, which is 1005. For this question, we need to work out an estimate for the mean length of a song. We're going to start by filling in the midpoint column. So looking at the first group of times from 0 to 100 seconds, the midpoint of that is 50. The next group from 100 to 200, the midpoint of that is 150. And then the final group from 200 to 300, the midpoint is 250. So when finding the mean, you then want to multiply the midpoint by the frequency. So I need to do 1 times 50, 8 times 150, and 7 times 250. 1 times 50 is just 50, 8 150s are 1200, and 7 250s are 1750. We then need to add up this final column here, and that gives you a total of 3000. And then we divide this by the total number of songs. Now you can get the total number of songs by adding up the frequency column here, which gives you a total of 16. But we also knew that because we were told it in the question. It said there were 16 songs. So we just need to divide this 3000 by 16, and that gives us the answer 187.5 seconds. For this question, we have 3 statements, and we need to tick the right box for each one. So let's start with the first statement. It says the coordinates of the y-intercept are 0, 3. Now the y-intercept is where the line crosses the y-axis, you can see that here, and that is at 0, 3. So that must be true. Now if we look at the second one, it says the gradient of the graph is -1. If a graph has a negative gradient, it will be sloping the other direction. You can see our graph is sloping upwards, so it must have a positive gradient, in which case it cannot be -1. So this cannot be true. And for the final statement, it says the gradient of the graph equals 2. Now it does say in the question that Veronica has forgotten to label the x-axis. So the gradient will depend on how we label it. So if we labelled it like this, where each square represents 1 unit, and then found the gradient, we draw a gradient triangle like this, and we can see the change in x is 1, the change in y is 1, and to find the gradient I do the change in y divided by the change in x, so 1 divided by 1, which is 1. So it's certainly possible to have a gradient of 1, but the question said the gradient is equal to 2. So is there a way of having a gradient of 2? Well, what if we use the difference scale? So rather than 1 square being 1 unit, what if 2 squares were 1 unit? Something like this. Well, if we draw a gradient triangle this time, now going across here, it looks like it's 2 squares, but that's still 1 whole unit, because we go from 1 to 2 on the x-axis. Vertically though, the change in y goes from 5 to 7, which is still 2. So the gradient is the change in y divided by the change in x, which is 2 over 1, which is 2. So it is possible for the gradient to be 2, but it could also be 1. In fact, it could be many other numbers. So this one could be true. For this question, we've got Gareth who's going to invest £5,000 into a bank, and we know it's compound interest of 3.5%. We're told that Gareth wants to withdraw the money once he's made over £1,000 in interest. So if he's made over £1,000 in interest, we can just say £5,000 add £1,000 is £6,000. So we need to work out what year he's going to hit more than £6,000. So let's work out the amount of money he has for the first year. So we would do 5,000, the amount of money he invests, times a multiplier for a 3.5% compound interest. Now a 3.5% compound interest is a multiplier of 1.035. So if we do this for the first year, we just multiply it by that, and your calculator will give you this number here. So at the moment we're nowhere near 6,000, so it's definitely not 1 year. So let's try it for 2 years. If it were 2 years, we do 5,000 times 1.035, but squared to represent the 2 years. If you type this in, you end up with this number. So we're still some way off. If you do it for 3 years, it's 5,000 times this 1.035 cubed, and that gives you this. And then we can go for 4 years, and that's this. 5 years is this. And we're still not there, but we're close, and 6 years gives you this. So at 6 years, you can see we've gone above £6,000, so he now has at least £1,000 in interest. So the answer to this question is 6 years. The first thing we're going to do in this question is take triangle A and translate it by the vector 0, 2. When you take a vector like this one here, the top number tells you where to move left or right, and in this case 0, so we're going to not move left or right at all, but the bottom number tells you whether to move up or down, and since it's positive, we're going to move up. So this vector is just a movement of 2 up. Now what we're going to do is draw that shape A, and then move it up 2 squares, so move it up 1 square and it will go here, and a second square and it will go here. And then it says to describe the single transformation that maps triangle B onto C. So we need to work out how we can get triangle B to map onto C. Now you can see the triangle's been turned round, so it's definitely a rotation. So what we would do at this point is take a piece of tracing paper, and then place our pen somewhere on the page and turn the tracing paper until B lands onto C. Now this can be a bit tricky to do at first, but with practice you'll get used to it. So it turns out the correct place to put your pen in this one is here. So at 5, 4.5. Now if you turn your tracing paper round half a turn, you'll see it will map straight onto C. So to describe this transformation, we need to give a bit of information. We first of all need to say it's a rotation. Then we need to say how many degrees we went and which direction. So I'm going to say it's 180 degrees. And I'm going to say clockwise, although for 180 technically you don't need a direction. You would if it was 90 though, or 270. And finally we give the point we've rotated it about. So that has coordinates 5, 4.5. For this question, we're told the sum of the first 3 terms of this sequence is equal to 21. And we first of all need to assume that the sequence is an arithmetic sequence. If it's an arithmetic sequence, this means to get from one term to the next one, you're either going to add on a number or take away a number. So to get from 1 to A, we need to add on some number, and then to get from A to B, we need to add on the same number again. We just don't know what that number is. But we do know the sum of all those 3 terms is 21. So the sequence starts with 1. Let's just say the difference between those terms is 1. So we add on 1 to get A, which gives you 2, and then we add on 1 again, which will give you 3. So the sequence goes 1, 2, 3. So if we add up those numbers, we need to get 21, and obviously that doesn't, it gives you 6, so we're quite far away. What if instead, to get from one term to the next, it was add on 2? So we start with 1, then we add on 2 to get 3, then we add on 2 to get 5. What if we add all those up? Do we get 21? Absolutely not, we end up with 9. So you can keep trying possibilities, and eventually you'll realise that if you start with 1, and then add on 6, you get 7, and add on 6 to that, you get 13. And if you add 1, 7, and 13, you do get 21. So the question wants to know the values of A and B, which are the second term and the third term, so the second term was 7, and the third term was 13. Now we're going to repeat the same process, but instead it's a geometric sequence. For a geometric sequence, to get from one term to the next rather than adding or subtracting, you're going to multiply or divide. So, we're going to start with 1 again, and we're also aiming for a sum of 21. So what if it was multiplied by 2 each time? We'd go 1, times that by 2, which is 2, times that by 2, which is 4, so we've got 1 plus 2 plus 4, which gives you 7. So that's clearly not the answer. So what if it was times 3? We'd start with 1, times 3 is 3, times that by 3 is 9, and if you add those together you get 13. So we're still not quite there. It turns out it's multiplied by 4. So we start with 1, we multiply by 4, which gives you 4, we multiply that by 4, which gives you 16, and if you add 1 and 4 and 16, you do get 21. So in this one, A, the second term is 2, and C, the third term is 16. In this question, we've been told the ratio of AB to AC is 4 to 1. This just means that AB is 4 times as long as AC. So let's call AC some letter, let's call it Y, and then AB will be 4 times as long as that, which is 4y. Then we've been asked to use trigonometry to find the value of x. So let's label the sides first of all. AB, where that 4y is, that's the hypotenuse. We've then got CB, which is the opposite, and then AC, which is the adjacent. Now in this question we don't need the opposite, so we can ignore that, and we're just dealing with A and H. This means we're dealing with cos, because of SO, CA, and TOA. And CA, C-A-H, is the only one that has A and H in it. So we can write out cos of x, which is the angle, equals the adjacent, which is y, divided by the hypotenuse, which is 4y. Now here you can just cancel out the y's. So if you divide by y on the top, you get 1, and if you divide by y on the bottom, you get 4. So this is just the same as 1/4. Now to find x, we just do inverse cos, so we need to do x equals inverse cos of 1 over 4 or a quarter, and type this into your calculator and you'll get the answer. So the answer to this question, rounded to one decimal place, is 75.5. In this question, we need to work out the cheapest price for 20 lollies, and we're given some information about the lollies here. We can buy them in 3 ways: a single, a pack of 4, or a pack of 12. So before we do this, we want to work out which of the deals is the best value. So looking at the single lolly there, it's 16p per lolly. Looking at a pack of 4 lollies at 85p, if we do 85 divided by 4, we find the cost of 1 lolly, which is 21.25p per lolly. So that deal is not very good at all because a single lolly is 16p. If we do the same process for the bottom one, we take the £1.74, which is 174 pence, divide it by the 12 lollies, you find that each lolly costs 14.5p. So that's actually the best deal. It's even better than the 16p for a single lolly. So we want to use that pack of 12 lollies as much as possible. But since we only want 20 lollies, we can actually only use it once. If we used it twice, we'd end up with too many because we'd have 24 lollies. So what we're going to do is buy a pack of 12 lollies once, that gives you 12 lollies, and then use the single lolly deal, since that's better value than the 4 lolly deal, to buy all the rest of the lollies. So if we need 8 more lollies to make 20, we're going to buy 8 singles. So one pack of 12 costs £1.74, and 8 single lollies is 8 lots of 16 pence, and if you add all of that up or type it into your calculator, you'll end up with £3.02. In this question we have 72 people, and we're told that 5/12 of those people did some revision. So let's first of all work out what 5/12 of 72 people is. To do this, we do 72 divided by 12, which gives you 6, and then take that 6 and times it by 5, which gives you 30. This means that 30 of the people did some revision. Now looking at the Venn diagram, we've got a circle R there for the revision, this circle. This means the total frequency for that whole circle must be 30. Now we can't do anything with that number yet, but we're going to come back to it later on. Now let's move on to the next line. It says 26 of the people did no revision and also failed the test. Now if they did no revision, they're not in the revision circle, and if they didn't pass the test, they failed it, they're not in the pass circle either, in which case they must be outside of both of those circles. So there are 26 people down here. Now moving on to the next line, it says 60% of those who passed the test did some revision. Now earlier on we said that the blue circle represents 30 people, and we've just put 26 people in that outside section there. So the only section we haven't considered is this one here. Now the whole Venn diagram needs to represent all 72 of those people. So if we know there are 30 in the blue circle, 26 on the outside, we can work out how many are in this red section here by doing the total number of people, take away the 30 from the blue bit, and take away those 26. So if we do 72, take 26 and take 30, we find that red section there must be 16. So let's pop a 16 in that section there. Now let's return to that statement. It said that 60% of those people who passed the test did some revision. Now if you think about it, this means that 40% of those people who passed the test didn't do any revision. So 40% of those people who passed did not revise. Now looking at the Venn diagram, that's represented by these 16 people here. They're in the pass circle, so they passed the test, but they're not in the revise circle, so they didn't revise. So 40% of that circle is represented by 16 people. So let's write that down. 40% equals 16. Now if you divide both sides of that by 4, you find that 10% equals 4. Then if you times both sides of that by 10, you get 100% equals 40. This means the whole of that pass circle must represent 40 people. Now we've already got 16 people in that pass circle, and if it needs to make 40, there must be 24 left. So we can put a 24 in the intersection of this Venn diagram here. That only leaves one section of the Venn diagram to fill in. Remember earlier on we said that this circle here represented 30 people? Well, there's 24 in it now, so the other side of that must be 6. And now the Venn diagram's complete. In this question we're told that the height of a cone is increased by 32%, and then we're asked to work out the percentage decrease in the radius of the cone so the volume remains the same. So let's write down the formula for the volume of a cone, we're given that. So for this cone it must be 1/3 times pi times r squared times h. But then we're going to change some of the lengths. So the height is going to be increased by 32%. This means we multiply it by 1.32. So instead of being h tall, it's now 1.32h tall. Then we're going to decrease the size of the radius to keep the volume unchanged. We don't know how much we're going to decrease it by though, that's what we need to find out in this question. So instead of it being r for the radius, it's going to be kr. And we don't know what k is yet, but it's how much we're going to change it by. So the volume of the original cone is 1/3 times pi r squared h. We've already written that down. But the volume of the new cone after those lengths have been changed needs to be the same as this. So this must equal 1/3 times pi times the new radius squared, which is kr squared, times the new height, which is 1.32h. So these two must be the same. On the left we have the volume of the original cone, and on the right we have the volume of the new cone, with the radius and the height changed. So if we times both sides of this by 3 first of all, that'll get rid of that third. So we end up with pi r squared h on the left, and then on the right we end up with pi times kr all squared, which we could write as k squared r squared, and then times 1.32h. Now on the right hand side we just have one term there all times together, so it might be better to write it as 1.32 k squared pi r squared h. Now notice both sides of this have pi r squared h. If we divide both sides by pi r squared h, on the left we'd end up with 1, but on the right we'd end up with 1.32 k squared. So we're nearly there now because we've nearly found the value of k. If we divide both sides of this by 1.32, on the left that would give you 1 over 1.32, and on the right that would give you k squared. You can now find the value of k by just square rooting both sides. So in your calculator type the square root of 1 over 1.32, and that gives you a k value of 0.8704, which is the same as 87.04%. So now that we found the value of k, we can see how much it's been decreased by, because to start at 100% and go down to 87.04%, you must subtract 12.96%. So the radius has been reduced by 12.96%. For this question we need to draw a histogram, so we're going to create a column for the class width. The class width is just the difference between each ends of your interval. So looking at the first interval, it goes from 0 to 15 minutes, and 15 take away 0 is 15. For the second interval, it's from 15 to 20, and 20 take away 15 is 5. And then if you do the same thing for the next two, it's 5 and 10. Then we need to work out the frequency density. To do this, you do the frequency divided by the class width. So we're going to do 6 divided by 15, 18 divided by 5, and so on. 6 divided by 15 gives you 0.4, 18 divided by 5 is 3.6, 15 divided by 5 is 3, and 8 divided by 10 is 0.8. Now we've got the frequency densities, we can draw the histogram. So we're going to draw a bar from 0 to 15 minutes with a frequency density of 0.4. So that goes here. Then for the next one, it's from 15 to 20 with a frequency density of 3.6. So something like this. And the next one, from 20 to 25, the frequency density is 3. And that looks like this. And for the final one, from 25 to 35, with a frequency density of 0.8, looks like this. And that's your completed histogram. In this question, we've got Felix, who's rolling an ordinary fair dice. So he's going to roll the dice repeatedly until he rolls a number 6. And when he rolls a 6, he's going to stop. And we've been asked to work out the probability that he takes exactly 4 rolls. Now if he takes exactly 4 rolls, he needs to fail on the first 3. So we're going to write the probability that he fails first, then he fails on the second roll, then he fails on the third roll, but on the final roll he's successful and he gets a 6. So what's the probability he fails on the first roll? Well, he fails if he gets any of the numbers from 1, 2, 3, 4, 5. So that's 5 numbers out of a possible 6 numbers, so the probability of failing is 5 over 6. Then failing on the second go is exactly the same, it's 5 over 6. Failing on the third go is exactly the same, 5 over 6 again. And then on the final throw there, the fourth throw, he needs to be successful. Well, there's only one way he can be successful if he rolls a 6 out of the 6 numbers, so times 1 over 6. You can then just put this straight into your calculator, and it will give you 125 over 1296. For the second part of this question, we've still got Felix rolling his dice, and we need to work out the probability that it takes more than 3 rolls to roll a 6. To work out the probability of it taking more than 3 rolls, we're going to do 1 take away the probability of 1 roll, or 2 rolls, or 3 rolls. So we just need to work out the probability it takes 1 roll, 2 rolls, or 3 rolls, and subtract all of that from 1. So let's start with one roll. What's the probability he only rolls it once? Well, he needs to be successful straight away, so that's 1 out of 6. What's the probability he takes 2 rolls? Well, he needs to get it wrong on the first roll, so he needs to fail, which is 5 out of 6, and then he needs to get it right on the second roll, which is 1 out of 6. So times in 5 over 6 and 1 over 6 is 5 over 36. Now what about 3 rolls? Well, if he gets it right on the third go, he fails on the first one, so that's 5 over 6, he fails on the second one, 5 over 6, but then he's successful on the final one, 1 over 6. So if you type that into your calculator, you end up with 25 over 216. Then we just need to take all 3 of those away from 1. So we do 1, take away all 3 of those. And if you type that into your calculator, you end up with this as the answer, 125 over 216. For this question, we need to solve a quadratic equation. There's a big clue in this question because it says give your answers to 2 decimal places. So this is the equation we're going to solve. Now at the moment it's not in the right form, we need one of the sides to equal 0. Given we've got a negative x squared on the left hand side, I'm going to get all of the terms to the right hand side so that it's 0 on the left. So to do this, I'm going to add 2x squared and subtract 6 from both sides. If I do both of those on the left side, I get 0. Then on the right hand side, I've got 5x, and I'm going to add 2x squared, so that's plus 2x squared, but then minus 6, so minus 6. Now this isn't normally the order we write a quadratic in, we normally have the x squared bit first, so let's rewrite it like this. We now need to use the quadratic formula to solve this one, since you can't factorize it. So you'll need the values of a, b, and c. A is the coefficient of x squared, which is 2, b is the coefficient of x, which is 5, and c is the constant term at the end here, which is negative 6. Now we just use the formula, which is x equals negative b, now we've got b as 5, so that's negative 5, plus or minus the square root of, then it's b squared, and we've got b as 5, so that's 5 squared, minus 4 times a, which we've got is 2, and then times c, which we have is negative 6. And then we divide all of this by 2 lots of a, and we've got a as 2, so 2 lots of that is 4. Now what I advise people to do next is type in the whole calculation that's inside the square root. So not the square root bit itself, but just type 5 squared, take away 4 times 2 times negative 6. And that gives you 73. So we can rewrite this as x equals negative 5 plus or minus the square root of, and then all of that was calculated to give 73. Divide by 4. Then we can separate this into the 2 solutions, so one where we use the plus and one where we use the minus. So it's x equals negative 5 plus square root 73 over 4, and x equals negative 5 subtract square root 73 over 4. So if you type both of those into your calculator, you just need to round your answers to 2 decimal places like it says in the question. You end up with x equals 0.89, and x equals negative 3.39. For this question, we've been given an iterative formula here, and the first value, u1, which is 14.5. We need to use those to work out the values of u2 and u3. So we're going to start with u2. What we do is we copy out that formula above, so where it says the square root of un over 2 minus 1, but we replace the un there with whatever u1 was, so the 14.5. So it's the square root of, then it's our 14.5, divide by 2, minus 1. You can just type that straight into your calculator and it'll give you 2.5. Then to work out u3, we do the same process, but instead of putting u1 in, we put u2 in. So to get u3, we do the square root of, now this time it's not 14.5, it's the 2.5 that we just worked out. Divide by 2, subtract 1, and again just use your calculator for this and it'll give you 0.5. So u2 is 2.5 and u3 is 0.5. In this question, we've been asked to work out the area of triangle BDE. To start this question, we're going to look at this red triangle here. We're going to use the sine rule to try and work out the length of line BE. So we're going to label the triangle, we'll label BE as A, and then the angle opposite that as capital A. And then we'll label the 9 as B, and the 50 opposite that capital B. Now you don't want to get confused by the A, B, C, D, and E you can see on the vertices there. They're nothing to do with what we're going to do in this question, they're just labels. Some of them happen to be A, B, and C, which is unfortunate, but it doesn't impact what we do. So now we use the sine rule, which is A over sine A equals B over sine B. And we can plug those numbers in. So we don't know what A is, but we know capital A, which is 100, and then little b, which is 9, and then capital B, which is 50. We can then multiply both sides of this by sine 100 to end up with a equals 9 sine 100 over sine 50, and you just type that straight into your calculator and you'll get this number here. So that's the length of little a, and let's replace that on the diagram. Now we're going to look at the triangle on the other side, this blue one here, and we're going to use the cosine rule to find the length of BD. Now we're going to label this triangle, but once again, don't be confused by the B, C and D that are the vertices of this triangle. They're nothing to do with the cosine rule. So what we need to do now is label the side we're trying to find as A, the other two as B and C, and then the opposite angles as capital A, capital B and capital C. Then the cosine rule says that a squared equals b squared plus c squared minus 2bc cos capital A. So little a, which we don't know, squared, equals b squared, which we do know, that's 8 squared, plus c squared, which is 6, so 6 squared. Take away 2 times b times c, so 2 times 8 times 6, and then cos of capital A, which is cos of 130. Now this whole right hand side there you can type straight into your calculator, and you'll end up with a squared equals this. Then you can just square root both sides of that to get a equals the square root of this number here. And then if you square root that, you'll end up with the answer for a, which is 12.716, and so on. So let's also pop this onto our diagram. Now we're almost there. We're going to look at the middle triangle now here, and we're going to use the area of a triangle formula, which is the area of the triangle equals half AB sine C. Now when we use this formula, the A and the B are the sides in the question, so let's say that A is 11.57 and the B is the 12.7, and then the C is the angle that we're given here, 74. So we're just going to plug those numbers in. It's 1/2 times A, which was that 11.57 and so on, times the B, which is the 12.7 and so on, and then times sine C, which is sine of 74. Now, if you type that into your calculator and make sure you use the exact numbers you were given for the 11.57 and the 12.7, and then round your answer off to one decimal place, you'll end up with 70.7. That was fun, wasn't it? In this question, we've been asked to show the gold collector can be sure that the bar is not made of pure gold. Now, if you look in the question, you can see we're told the density of pure gold is 19.3. So we need to show that the density of this bar cannot be that. In fact, it must be lower than that. So to do this, we're going to use the formula density equals mass divided by volume. Now we're given the mass in the question, that's 1 kilogram, and we're told it's exactly 1 kilogram, so it's not going to change. But we're not given the volume, so we need to work out the volume. But this question is actually about bounds. We need to work out the greatest possible value for the density, and then we're going to hope that that's lower than 19.3. So how would we work out the maximum density? Well, considering the mass is fixed and we can't change that, we just need to consider what the volume could be. Now we can get an upper bound and a lower bound for the volume. Since we're doing mass divided by volume, and we want the maximum density, we want to choose the minimum volume. This is because when you do the mass divided by the smallest possible number, you'll get the greatest possible answer, and the greatest possible density. So for this question, we need to work out the minimum possible volume for this bar. So, you'll notice this bar's a prism. You can see it's got a trapezium for its face here. So let's label on the lengths. We've got A and B, which are the parallel sides of the trapezium. And then we've also got the height of the trapezium, we'll call that H. And then the length of the prism, we'll call that L. So let's write down some error intervals for all of those lengths. For A, we've got 1.9. So the lower bound is 1.85 and the upper bound is 1.95. For B, it's 4.1, so the lower bound 4.05 and the upper bound 4.15. And for H, 1.8, so 1.75 to 1.85. And finally for L, 10.2 is 10.15 and 10.25. So these are the bounds for the possible lengths for all of the sides of that prism that are relevant. Now remember, we want to work out the minimum possible volume so we get the maximum possible density. So we're going to use all of these lower bounds here. So using those numbers, let's work out the volume. First of all, we find the area of that trapezium, which is 1/2 of A plus B, so we'll use the lower bound of A plus the lower bound of B, and then times this by the height, so we'll use the lower bound of the height, and then once we've got that, we times it by the length of the prism, so the lower bound of that as well. Typing all of that into your calculator will give you this number here, which is the volume of that prism. So we now need to work out the density using this volume. So the density is the mass, which is 1 kilogram, which we could write as 1,000 grams. We need to be careful because the units of density are in grams per centimeter cubed. So 1,000 divided by this volume, which gives you this number here. And you can see that's our maximum possible density, which is lower than the density of pure gold. So if we just write that this is less than 19.3, we've now shown the bar cannot be made from pure gold. In this question, we've been asked to work out the value of d, which is the distance that Robin stands from the target. Now this graph above shows you the different average speeds and the different times taken for lots of different arrows. We can therefore work out the distance d by doing distance equals speed times time. We can pick any point on this graph, so I'm going to pick this one here, so where we have 2 seconds and 30 meters per second as the average speed. So if we do the average speed, which is 30 times the time 2, you end up with 60. And as I said, it doesn't matter which point you choose. If you chose this one here, where it was 3 seconds and 20 meters per second, you still do 3 times 20, which is 60. And if you chose 1 second, you do 1 times 60, which is of course 60. For the second part of this question, we're told the distance x is directly proportional to the average speed, s. And we're told that when x equals 60, s equals 80. So if x is directly proportional to s, we can write x equals k, some constant, times s. Now we can substitute in the values we've been given, so x is 60, equals k times, and then we're told that s is 80. If we now divide both sides of this by 80, you do 60 divided by 80, which gives you a k value of 0.75. So we can rewrite this formula now, x equals k times s, as x equals 0.75 times s. We're then asked to find the time taken to hit the target if we draw the string back 36 centimeters. So drawing the string back 36 centimeters means that x is 36. So let's substitute that in. 36 equals 0.75 s. Divide both sides of this by 0.75 and you find that s is equal to 48 meters per second. Now that's not the answer to the question, that's just the average speed. They've asked us for the time. So if you return to the graph now and draw a cross from an average speed of 48, you'll find the corresponding time is 1.25 seconds. And that's the answer to the question. For this final question, we've been told that gf of 5 equals 41. Gf of 5 is a composite function. So what we're going to do is first of all find f of 5 and then put whatever we get from that into the g function. So let's start by finding f of 5. F of 5 just means we replace all of the x's in the f function with 5s. So instead of 2x plus k, it's 2 lots of 5 plus k. 2 lots of 5 is obviously 10, so it's 10 plus k. So this is the value of f of 5. Now we're going to put that inside the g function since it says g of f of 5. So if we put 10 plus k into the g function, what does that mean? Well, if we go up to this g function here, everywhere where we see an x, we need to write 10 plus k. So to do gf of 5, we've got x squared, but we know that x is 10 plus k, so 10 plus k squared, minus 3 lots of x, but x is this 10 plus k, and then plus 1. Now there's lots of expanding out to do here. That first bracket 10 plus k squared is really a double bracket, and then we've got this on the end. So let's start with a double bracket. 10 times 10 is 100, 10 times k is 10k, k times 10 is 10k, and then k times k is k squared. Then for the single bracket, we've got negative 3 times 10, that's negative 30, and negative 3 times k is negative 3k, and then finally this plus 1 at the end. So we've got loads of terms here we need to simplify. We'll start with the k squareds. There's only one of those, so it's just k squared. Then onto the k's, we've got 10k plus 10k, that's 20k, and then subtract 3 more k, so that gives you 17k. And then for the constant terms, we've got 100, take away 30, that will leave you 70, and then plus 1, so 71. So this is the value of gf of 5. But we've been told in the question up here, gf of 5 is 41. So we can write this quadratic here equals 41. We can now just solve this. Let's take away 41 from both sides, so the right hand side is 0. That will give you k squared plus 17k plus 30 equals 0. And then we can solve this by factorising. So if you factorise it, you get k plus 15k plus 2 equals 0. And that gives you your 2k values. From the first bracket, k equals negative 15. And the second bracket, k equals negative 2. Thank you for watching this video. I hope you found it useful. I've put some suggested grade boundaries here. They do vary every year, but they're roughly around these sorts of numbers, so they'll be a good guideline for you. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.